Hello everyone, happy learning. In this video, we will try to understand a new optimization technique that is designed by mimicking behavior or processes found in nature to solve complex problems. So first we will try to understand what are these algorithms and how they work and why we are using only these algorithms. So instead of solving a problem directly with strict formulas, these algorithms imitate natural behavior. Second, they adapt and evolve solution over time and search for the best answer gradually. Now let's see simple examples where we are using these algorithms to solve different real life problems. First we have PSO algorithm, that is particle swarm optimization. In this algorithm, birds find the shortest path to the food. Second, we have ACO, that is ant colony optimization. In this algorithm, ants find the optimal routes to the resources. And here you can see the real life application where we already applied these algorithms to find the best solution. So here, researchers or scientists, they copy these strategies to solve problems. So the inspiration is here, nature. They get inspired by these natural phenomena and then they use these strategies and then they use their behavior. So and they use these strategies to solve optimization problem, machine learning task, and engineering design problems, and many more you can see here. Next question is why we are using these methods. So when the traditional methods either fail or they take too much time to solve any problem, we use meta-heuristic optimization techniques. Because in traditional method we need smooth equation and sometimes they easily stuck and not give us the answer, and sometimes traditional methods take too much time and then they will give you just one single answer. But bio-inspired techniques work well for complex and messy problems and they explore many possible solutions at once. Instead of just one single solution, they will give you multiple solutions. The next question is how they generally work. Now let's understand the working of these algorithms. So first step, we will initialize the population. We start with many random solutions. So here we can initialize the population. So here we can initialize n number population, means we have n number search agents. We will use these search agents to find the best solution. So when the population is initialized, then we will evaluate how good each solution is. So after this, we will use here fitness function and evaluate each solution. Then we will update them using the rules inspired by nature. So different natural phenomena we will use and update the solutions, and we will repeat this process until we find the good or optimal solution. So this is a simple procedure that we follow for all algorithms. Now let's connect the idea of bio-inspired optimization directly to the Golden Jackal Optimization Algorithm. So this algorithm is inspired by the behavior of Golden Jackal. Golden Jackal, that is wild animal known for hunting in pairs, for smart coordination, and for their adaptive strategies. So researchers observed this behavior and they used it as inspiration, and we have this algorithm, that is Golden Jackal Optimization Algorithm. So this is a swarm-based meta-heuristic algorithm, and this algorithm simulates the hunting behavior of Golden Jackal. And this algorithm is similar to Gray Wolf Optimizer or PSO. So Golden Jackal, they typically hunt in pairs. We have male and female in pair, and they uses and in pair they track, and here first they tracking. So here they perform different action like tracking prey and circling prey, then attack at the right moment. So first they will track the prey, then surrounding and disturbing the prey until it ceases to move. After this, finally they will attack the target. So this algorithm is inspired by key steps in how a golden jackal hunts its prey. First, search, then they approach the prey. After this, round and harming the prey until it ceases movement. And in the last, they will attack and capture. Now let's try to understand this algorithm working, how this behavior is simulated in this algorithm to solve the optimization problems. And we will see all the mathematical equations That is the mathematical model they use in this algorithm. In step 1, we will initialize the population. So here n number of search agent we can use as the population size. So population we have here group of jackals, that is our candidate solution. So we'll start with multiple solution, that is our pack of jackals searching for the food. After this we will evaluate the fitness value. So using a fitness function we will evaluate each candidate solution. Then after this we will start the main loop, and here we will set the maximum number of iteration, how many times we will repeat the loop, and after that we will display the best solution. So we will initialize the coordinates. So here we have male jackal and female jackal position. Male jackal, that is the best prey, and here we will consider, so here we have male jackal position and the female jackal position. So we will consider the male jackal, that is the best prey, and female jackal, that is the second best prey. Here for every prey we will update their position. We will perform here exploration phase and exploitation phase. So using this equation, first we will revise the energy, then we will check whether this is greater than equal to 1 or it is less than 1. If energy is greater than or equal to 1, then we will perform here exploration phase. It means we will explore the search space. If this is less than 1, then we will perform here exploitation phase using these equations. So here you can see the mathematical equations that we will use in the exploration phase and in the exploitation phase. After this, we will revise the location using this equation, and then we will increment the counter in the current iteration +1 and repeat the loop until the maximum iteration. So we will repeat the loop until the maximum iteration and then display the output, that is the best solution found so far. So here you can see this equation. So this is the final equation that we will use to update the position for the both prey. So here you can see we are using updating it. Now you can see the application where we can use this algorithm to solve the complex problems where the traditional methods struggle. We can use this algorithm in machine learning for feature selection, hyperparameter tuning, neural network optimization, in engineering design for antenna design, mechanical design, in power system for power flow optimization, economic load dispatch, in image processing for feature extraction, image segmentation, in wireless network for routing optimization and network coverage problem. Advantages: we have this algorithm is simple to implement, we have easy mathematical models and just few control parameters. And this algorithm having good exploration and exploitation phases, it means we have search. So this algorithm search globally and then refine the solution. And this algorithm avoid the local minima better. So we have random movement that help to escape the poor solution. And this algorithm is flexible. It can solve nonlinear problem, continuous problem, and multi-dimensional problem. And we have here fast convergence because we are using here pair hunting strategy that help to guide the search effectively. And different disadvantages: this algorithm can still get trapped in the local optima, and performance depend on the parameter. If poor parameter setting, it will reduce the efficiency. Then we have computational cost, that is the if we will use here large population, it will increase the computational time. So that's all about this video. In next video, we will try to understand this algorithm using numerical example, how this algorithm is used in real life to solve complex optimization problems. And we will try to understand this using different examples. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.